This podcast is brought to you by Enlightening Learners Academic Coaching and Tutoring Service.
In this presentation, we're going to learn how to use the distributive property to evaluate expressions. Some ideas that you're going to need to know. You're going to need to be able to define the term distribute, use the property to simplify expressions, and to identify real-life applications for use in the distributive property. This distributive property allows you to multiply each number inside a set of parentheses by a factor outside the parentheses and find the sum or difference of the resulting products. To distribute means to separate or break apart and then dispense evenly. Sometimes it's faster to break apart a multiplication problem and use a distributive property to solve or simplify the problem using mental math strategies. The distributive property is linked to factoring. When you factor problems, you identify what numbers or variables a problem has in problems. You identify what numbers or variables the problem has in common. When you distribute, you multiply the common numbers or variables for the numbers that have been grouped together. So this is what it means. Let's assume that we're making a pizza. And the recipe calls for 2 ounces of pepperoni, 3 ounces of cheese, and 1/2 cup of tomato soup. Together, these things make our pizza, so we're going to add them together. Now that'd be perfect if the recipe called for 1 serving, but we have to make enough for 5 people, so we need to make 5 servings. I would multiply this whole thing out by 5. Now, in order to make enough for everybody, I've now got to have 10 ounces plus 15 ounces plus 5/2 or 2.5 cups of sauce. If you look here, you'll see that when I multiply, I have B and C being multiplied to A. A times B is AB, and A times C is AC. I can also use a distributive property when I'm subtracting. A times B is AB, and A times C is AC. Once these ideas have been multiplied, I can combine them together. Okay, so I can multiply 67 times 9 to get 603 using my regular math technique. Or I can take 60 and add it to 7, because that's still 67, and this time I'm going to multiply it using distributive property by 9. 9 times 60 is 540. 9 times 7 is 63. And when I add the two, I get 603. Now, I can also use, rather than using addition to do it, I can say 70 minus 3 and multiply that by 9. Because 70 minus 3 still gets me to 67. 9 times 7 is 63, so 9 times 70 is 630. 9 times 7 is 27. When I subtract the 2, I get 603. Okay, once again, I can multiply 48 times 7, or an easier way to do it is to say 7 times 50 and to subtract 2 from that. 50 minus 2 is 48, so I haven't really changed anything. I'm just using my distributive property to make the numbers a little more accessible. 7 times 50 is 350. 7 times 2 is 14. 350 minus 14 is 336. This works with multiple numbers as well. I can take 473 and break it apart into 400 plus 70 plus 3. And multiply that result by 6, and that's what I've done in this example. 400 plus 70 plus 3 still gets me to 473. Multiplying it by 6, I get 6 times 400 is 240. 6 times 70 is 420. 6 times 3 is 18, and when I add them all together, I get 2,838. Now, in algebra, you'll see problems like this where you have an unknown, where you have a variable and a non-variable number. Well, same principle applies. I know that I can't combine these because these are unlike terms, but I can still distribute the 5 to everything inside. 5 times 3n is 15n. 5 times 4 is 20. And at that point I'm finished because I can't distribute anymore and I can't combine the 15n and the 20.